Alright, it wouldn't be thermochemistry if we didn't do some math. So this one's going to be over calculating specific heat. And here's your equation. Q equals Cm delta T. Most of the time you'll hear me call it the MCAT equation because I'm going to write it as Q equals MC delta T. Looks like MCAT. That's how it's written on your formula chart as well, is Q equals MCAT. M stands for mass, Q is heat, C is the specific heat, and the delta T is a change of temperature. Do not be intimidated by this formula, it's very easy to use. So, yeah, the delta means change in. Change in means temperature final minus temperature initial. We use that a lot. So specific heat capacity, CP. Okay, specific heat capacity is the amount of heat required to raise 1 gram of substance 1 degree Celsius. It's very similar to another one we've had. We'll talk about those in class a little bit. But this is an intensive physical property, which means it's not going to change depending on how much we have. So specific heat of water is always going to be the same constant, which is that 4.184 that we talked about in the last video. You need to know that. It's on your formula chart, but you're going to use it a lot, so you might as well go ahead and memorize it. Now, what do these actually tell us? Is that the low specific heat capacities are able to change temperature relatively rapidly. So they conduct heat very, very well. So these are going to be your metals. So when you're cooking with things, you want a metal with a low specific heat, so your pot heats up faster and more evenly. High specific heat, I don't know why these are shifted down so much, but they take longer to heat up because they will absorb large quantities of heat. Yeah. So you want these for the insulators. Sorry, this is so bad. And normally these are easy to find because they tend to be shiny, but not metals. So this would be like a plastic or cotton, things like that nature. So here are a few more formulas that you need to know. That one we already discussed. This is your MCAT formula. Now you also have this enthalpy of fusion. Enthalpy just means heat, and it's delta H equals moles times heat of fusion. We will give this to you, and we will give this to you. So when you see those, you just multiply them together. Same with the heat of vaporization. We're going to give those to you again. So you just need to know to multiply these two things together, and that's all you really need to know. So you have your first example. Calculate the enthalpy change that occurs when 10 grams of water at 96 degrees cools to 50 degrees Celsius. So we're trying to find the enthalpy, which is going to be Q. Our M is 10 grams, and our C of water is always 4.184, and then our delta T is temperature final, which is 50, minus temperature initial, which is 96. It will give you negative 46 degrees. So you plug it in. Q equals MC delta T. Your M was 10 times your C of 4.184 times your delta T of negative 46. Be very cognizant of that negative sign. It becomes very important very soon. That will give you a Q of negative 1925. That'll be in joules. Very soon you'll see that negative sign, or that's an exothermic reaction. That's why it matters. So keep on going on, more practice. We see heat of vaporization, we see moles. Remember when you see one of these H of vaps or H of fuse, you multiply them together. So 19.2 times 40.79 equals 78.3 joules. The next one, you have to calculate the energy release. So you're looking for Q. You have a mass of 1044.2. You have a specific heat of water, which is always 4.184. And you have a delta T, just temperature final, 32.3, minus initial, 98.6. And that will give you negative 66.3. So you plug it in. Q equals MCAT. So Q equals our mass, which is 1044.2, times our C of 4.184, times our delta T of negative 66.3. Do all that in your calculator, simple multiplication problem, and you get 28,966 joules, or 660, or 28.9, or 29.0 times 10 to the fourth joules. Sorry it's so sloppy, but you see the point. Number 3, you have a mass of 95.4, and you have a temperature change, so delta T is going to be final, which is 48, minus initial, 25. We're going to give you 23 for your delta T. Now this time you have a Q of 849. This joules right here is a dead giveaway, that's the Q. So now you're trying to find the C. So if we put our equation here, Q equals mc delta T, we're trying to find the C here. So we're going to keep that the same, and just divide the other two out, like all the other equations we've done this year. So that's going to be Q over m delta T equals C. And now you just plug it in. Q is 849, divided by your m, which is 95.4, times your delta T, at 23. Make sure you put those in parentheses. You're doing it all in one step. That will give you 0.0387. If we consider water to be 4.184, this is going to be a very, very low specific heat capacity, so this is most likely a metal, which it is, copper. Number 4, you have 435 joules. That's going to be Q. You have heat added. You have a mass of 3.4. You have a delta T of 85 minus 21, which will be 64. And then you're looking for the C. So it's going to end up being the same equation. Q over m delta T equals C. And the same way we did last time. Just plug everything in. 435 divided by 3.4 times 64. Use parentheses appropriately. And you get 2.0. So that's pretty easy math. We'll get into more easy stuff next video.